Hello everyone. So today's topic is loop. So what is a loop? Loop is a repeating structure. So when you want to repeat some work repeatedly for n number of times or for unlimited times, you can use a loop, right? So now we will learn about two kinds of loop. So there is a for loop and a while loop. Okay. So let's know the syntax for loop. So for loop uses a loop variable to iterate through the loop. Okay, so you have to place the variable here. Okay, for the iteration variable or the loop variable, then you can use the membership operator. Then we use a function called a range. This function will provide us the range between two numbers. Okay, so first of all we'll see we have the range with one single value. Then there is another form of for loop, another form of range, that is range with two arguments. So we have a initial point from where the loop is going to start. Then we have a final point where the loop ends. Then there is another form of range. So it has three arguments. So you have one initial point, one final point, and then you have a step. Okay. This step will decide whether you want to go in forward direction or in backward direction. So we will look into this with an example. So let's now jump into the code. First of all, I'm going to print numbers from printing numbers. I'm just going to print numbers or using the for loop. For I in, I is the loop variable in range of n. So n can be any number. So let's say n is 10. So when I say 10, okay, you will see when I print I, the loops, the I goes from 0. The starting point is 0. Okay. When you give one single argument in the range, you will always, the loop will always begin from the 0. The loop variable will start from 0. 0 till n, or the value inside the range function. Okay. So this is not included actually. This will be excluded. You can see now. See. So from 0 to 9 I'm getting. Okay. So if I say for I in the range 15. Okay. So I have to put a colon here. After putting the colon, when you hit enter, you are actually inside the for loop. You can look at the indentation. So you're inside the for loop now. So we can print I, your iteration value variable. Sorry. So you can see from 0 to till 15. 15 is not included. Okay. So from 0 to 14, there are 15 numbers only. Okay. When you say 0 to 9, you have got 10 numbers. Okay. So no problem in that. Okay. Suppose you don't want this range. Okay. You want a starting point and an ending point. So what you have to do for I in range, sorry, array and for I in range, you have a starting point. Like I say, I want to start from 1 and I want to go till 10. When I use 10, you see, you will get less than 10. The last value will be less than 10. Okay, right? So this is less than 10. So how can you get 10? So you have to write in the final value, you have to write one more. Okay, so you just increase the value by one more value. So 1 comma 11. When I write 11, I'm going till 10. So I'll be starting from 1 and going till 10. Okay, 1 to 10, right? So you can have your custom range. So like you want to begin from 20. So you can give your range from 20, comma, let's say 50. So I'll have to write 51. Okay. There you go. Starting from 20. Okay. Till 50. Okay. That's all. So now there is the third type of range we are going to learn. So for I in range, I'll say I'll begin from 1. I'll go till 20, and my each step will increase by 1. Okay. So normally it also increase by 1. So let's try something different. Let's say I'll increase every step by 4. Okay. So for my value of I, it will increase by 4. Okay. Initially it is 1, then adding 4 to it, next number will be 5. Then adding 4 to 5, you will get 9, the next value. Okay. You can see. Okay. 1, 5, 9, 13, 17. Right? After 17, when you add 4, it's 21, which is not in the range. So after 17, it gradually stops. Okay. Fine. So I hope you have some insight on for loop. Okay. So suppose you want to go in the reverse direction, like in other languages, we have the minus minus operator. Using it, we can go in reverse direction. So here, what you have to do? Okay. So here you can use negative step, negative step. Okay. So suppose I want to go from 20 till 5, 20 till 5. When I say print it, okay, so it's not possible. It's not possible when you say print from 20 to 5. Okay. Okay. So this is not possible. You have to guide your compiler saying that I want to go in reverse direction. So I'm on -1 step. So then only you are capable of going in reverse direction. See, now it's working. 20, 19, 18. Okay. Now you can see the final point. Final point is excluded. So till 5 you are going, not 5 is not included. So okay, it's more than 5, 6. Okay, that's the range. Okay. So you can go for negative range, like range of -2, -3. Okay. From 20 to 0, I'll say I'm going no -5. The step is -5. Okay. So print -5. Okay, save enter. So what happened? Oh, so print 5. Okay, sorry, that's my mistake. My bad. Okay, now I have entered the variable. So you can see 20, 15, 10, 5. So this is how you proceed in negative steps. Okay, in negative direction. Okay, in backward direction, you can go like this. Okay, now, so what are the use of for loop? Okay. So for loop is not for not just for printing numbers. You can do our many functions. You can repeat one operation repeatedly, repeat some operation, the operation you need to repeat. So for I in range of 5, so suppose I want to print my name 5 times. Okay, right? So I want to print my name 5 times. Okay. So in the range 5, I is running from 0 till 4. Okay, 4 is included, 5 is excluded. So 0 to 4, that is 5 times. Okay, I is changing its value. And print, which is inside the for loop, it will also be executing 5 times. Okay, see, right? So we can add the value of I here. Let's say I comma ben. So you can see the value of I and the number of times ben is executing, the printing statement is executing. Okay, right? So suppose you want a sum of numbers from 10 to 20, say. So you can do that also. So you need a variable s equals to 0. So this is the variable. Then I in range of 10. I'm beginning from 10 till 20. Okay. S equals to s plus I. So I is every number from 10 to 20. Okay. And with each iteration, I with a new value will get added to s. Okay. Finally, you have to come out of the loop so that you can print the final value. If you are printing it inside the for loop, okay. So the you will get wrong answers. At least you want the final value. Okay. So sum equals to s. So there you go. Sum is 165. Okay. Whatever you put inside a loop, it will execute repeatedly. So if you print put the printing statement inside the for loop, it will print the progress of the sum repeatedly. So which is not required. Okay. So suppose I want to print the factors. Print the factors. Factors of a number. So let me take input of a number. So n equals to int input. Okay. Give a number. That's the prompt. Then for I in range. Okay. So as we know, basically every number is divisible by 1. So 1 is a common factor to every number. So you have to start from 1. Okay. Then every number can divide itself. So you have to go till n. So if you write n here, then you will get less than n value at the end. So you need to write n plus 1 so that you can get n also in the range. Okay. So now what you have to do? You have to put a condition to check if it is a factor or not. So if the value n is divisible by I, so I is basically the number in the range of 1 and n. Okay. So if it divides, then it's a factor. Okay. So that's a condition. If n modulus I equal to 0, then it's a factor. I is a factor. I when I is dividing the number, so it's a factor. Okay. So print I. There you go. Okay. So if I say 20, so 20 is divisible by 1, 2, 4, 5, 10, 15, 20. Okay. So these are the factors of 20. Right. Okay. Right. So when you want to check if a number is prime or not, for prime, checking prime or not. Let's say prime or not. So take the input n equals to int input, enter a number. So I have the number now. Okay. Then after getting the number, what you will do? You shall count the number of factors. So prime number is basically a number which is having only 2 factors. So I'm going to count. Okay. So c equals to 0 for I in range of 1 comma n plus 1 colon if n modulus I equal to 0 colon c equals to c plus 1. Okay, so there you go. So that's the operation I need to get repeated inside my for loop. Then after the counting finishes, okay, the counting of factor finish, then you have to check what's the count. So if the count is 2, we can print it's a prime. Prime number. Else print of prime or composite, you can say. Okay, whatever you like. But let's say 50. 50 is not a prime number. Click in, hit enter. I say 23. 23 is a prime number because it has got only two factors, 1 and 23. 1 and the number itself. Okay. Okay. So hit enter. You say 2. 2 is the only even prime number. Okay. So it's working now. Great. Okay. So there are much more implementation of for loop. You can what you can calculate your factorial of a number. Then you can use nested for loop. Let's go for nested for loop, nesting. Okay. So now nesting for, okay, or nested for, you can say nesting of for loop. So if I want to print a pattern, okay, a pattern like this for I in array in the range of 5, colon, enter. I am inside the for loop, right? For every I, I'll have another for loop. Okay. For j in array in the range of let's say I plus 1. Okay. Okay. So it will print what? Print a star. This is the simplest type of thing you can do. So end is to keep your printing on the same line. Then I'm coming out of the inner for loop, then giving it a print statement which is empty just to change the line. Now let's run. You can see the star pattern. Okay. So you can use this number print I here. You can see. Okay. So print the j. Okay. So you can see how the inner loop is working. So 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. Okay. Okay. For the value of I, j is I plus 1. Okay. So that's how you can use the nested for. So suppose I want to collect all the or display all the prime numbers between a range of numbers, two numbers. Let's say so prime numbers in between let's say 10 and 50. So I will print all the prime numbers between 10 and 50. Okay, so that requires a loop, right? So one loop will provide me the values that is from 10 to 50, means 10, 50, 10, 20, 10, 11, 12, 13, 14, like that. I'll get the numbers. So I'm starting from 10 going till 51. Okay. So basically I is providing me the number. Then I need the count variable C, then a for loop, which is actually going to count the factors. Okay. So, 1, comma, I plus 1. I is every number, 10, 11, 12, 13, 14, till 50. Okay. So that's why I have to write I plus 1. Okay. So if your I is divisible by j, that means j is the factor. So C plus equals to 1. So this is a shorthand notation for C equals to C plus 1. You can write C equals to C plus 1. Otherwise, you can go for this C plus equals to 1. So it will eventually add the value 1 to C. Okay. Now let me come out of the for loop. Yes, in a for loop, I'm outside. So I have to write the condition. If C is equal to 2, then only you print the value, which is prime. So basically we were checking I to be prime or not, right? Okay. So I is the number in the range of 10 and 50. So let's run. So you can see, so all these numbers are prime numbers. 11, 13, 17, 19, 23, 21. So that's all. So these are all prime numbers. Okay. So there are lot more implementations of for loop. Okay. You can collect questions from internet or go through a book for more questions. Okay. Now there is another type of loop, which is while loop. Okay. So you can basically say for loop is a fixed loop. Why fixed loop? Because you know how many times the loop is going to run. Somehow you know. Okay. Because you are using the range function. Okay. Right. Inside the range, if you are writing 5, then you know the for loop is fixed for 5 iterations. Okay. When you say from 10 to 51, so 10 to 51 is 40 iterations are there. So for loop is a kind of fixed iteration. You know how many times the loop is going to execute. Okay, right? So there are certain times you don't know for how many turns you are going to use the loop. Okay, for how many turns you are going to execute the statements, right? In that case, you should go for while loop. Okay, so while loop, while loop syntax is very simple. Okay, so you just have to have a condition. While, then there is a condition. Okay. The loop have some body, the statement to be executed repeatedly. Now, unless and until this condition goes false, it will run for n number of times. Okay. That means, okay, as long as the condition is true, okay, the body of the loop gets executed. Okay. When it turns false, immediately the loop ends. Right? So that's the simple thing. That's a simple logic for using while loop. Okay. So let me show you. Let's say I have a number n equals to 1. Okay. We have used n for more enough times. Okay. So y. While a equals to 1. Okay. A equals to 1 is a variable having value 1. Okay. So while a is less than 10. Okay. You can print a. So I need to update the value of a. Okay. If I leave it like that, it will go continuously. Okay. For infinite number of times, endless times. So I need to update the value a plus equals to 1. So there you go. I'm increasing the value of a by 1 every time. Okay. Now you can see it's printing from 1 to 9. A is less than 10. So basically the loop goes like this. Okay. Let's make a dry run. So a is 1. Okay. For entering into the while loop, you need to check the condition. This is the condition. So 1 less than 10. So this is true. Since it is true, you are allowed inside the loop. Okay. Now your task is to print the value. So you printed. Then your task is to increase the value of a by 1. So you are increasing. What is it? A equals to a plus 1. So what was there in a? 1. 1 plus 1 is 2. So a is 2 now. So after that line, you have no more line. So you need to go up and check the condition again. So check for the condition. Now it is 2 less than 10. Yes, it is true. So for a true condition, you need to enter into the loop. You can enter into the loop. Now print the value for a. So it's 2. A is 2 now. Then after printing, you need to increase the value. So a equals to a plus 1. So 2 plus 1 is 3. So the value for a is 3 now. Okay. No more lines. Go up. Check the condition again. 3 less than 10. True. Again, dive inside. Print the value for a. Then increase the value of a. So it will be 4. then go on, so on, so on. It goes like that. Okay, you reach a stage where a is 9, right? After 9, after printing 9, you are increasing the value by 1 and getting 10 as a value for a. Okay, now when you go up, you check the condition 10 less than 10. So there you go, it's a false condition. 10 cannot be less than 10. Okay, so at that point, the while loop ends. Okay, the repetition will stop over there. Okay. Okay. So now, so this is something which is fixed actually, you can say, because a is having 1 and you have given a condition that a will run less than 10. Okay, run till less than 10 until it achieves the value less than 10. Okay, it will actively run till that point. Okay, now how can we say that it is unfixed? Okay, let's say for example, I have a number n. Okay, I have a number n and I want to reverse the value, right? Want to reverse the value. Okay, so let's take input of a number. Okay, I'm writing nothing here. Okay, no prompt. So now r equals to 0. So while n is greater than 0. So this is my condition. The loop will run until n is greater than 0. Okay, right? So what I'm doing here, okay, I'll be collecting all the digits. Okay, into 10 plus n mod 10. So there you go. So I'll be collecting all the numbers from the reverse order. Okay, then I will add it to R, include it to R. Okay, then floor division by 10. That will give me the remainder without any decimal point. Oh, sorry, the quotient without any decimal point. Okay, so this will help me in removing the last digit of the number. Now print the value of r. Okay, now so let's run. So I'm giving a number 50, 58. Say, okay, 58. So it becomes 85. The number is reversed. Okay, so as per the condition here. Okay, so you can say that it should run 58 times because 58 is greater than 0, 57 is greater than 0 when we go in a reverse order. Okay, so this should run for how many times? This should run for 58 times. Okay, right? But there is a catch. Okay, so what I'm doing, okay, this is the thing which is actually playing a big role here. Okay, this loop runs according to the number of digits in a number. So this is a 2-digit number, so this entire loop runs only 2 times. Okay, so now we can see the unfixed nature of while loop. Okay, it is not fixed. Okay, it is decided by the size of the digits in a number. Okay, the length of the digits in a number. So if I enter a 3-digit number, it will run for 3 times. Okay, so this is unfixed, right? Okay, so what goes in the code here is, so suppose you entered 58. Okay, we have taken the input. So r is 0, 58 is greater than 0, 58 greater than 0, true. So this is true. Dive inside. So there is this line. Okay, put value to this line. So R equals to R into 10 plus N modulus 10. Okay. So R is 0, 0 into 10 is 0 plus N modulus 10. What is N? N is 58. When you divide 58 with 10, you get 8 as remainder. So 8 got added to 0. Then R stores 8. Okay. R is having 8 now. Now N equals to N floor division by 10. Floor division. What do you mean by floor division? You do not have to collect any decimal point. Okay. Okay. Floor division will omit the decimal point. Okay. When you divide 58 with 10, you get 5.8. Okay. Right. 5.8 will give you 58 and you are getting remainder 0. So that's what not you are going to do with floor division. Okay. Floor division will basically avoid the point thing. Okay. So what did you get here? Okay. You got 5.8. So this gets omitted. So you are left with 5. Okay. 0.8 is removed. You are left with 5. That 5 got into N. Okay. Now there is no more line inside the for while loop. You are going to check the condition again. So 5, N is 5 now. 5 greater than 0, true. It is the loop. You are having R now. So what was the value for R? It was 8. So 8 into 10 plus N modulus 10. 5 modulus 10. So 5 is a very smaller number as compared to 10. So you cannot divide 5. Okay. So you get the same number as remainder. So this gives you 5 and this is 80. 80 plus 5 is 85. Okay. Right. So this is 0. This 0 gets stored into N in this line. N equals to N double slash 10. So N is storing 10 now. When you go up to check the condition again, it's 0 greater than 0, which is a false condition. Okay. The while loop stops. Right. Okay. So that's how your unfixed nature of while loop works. Okay. You can use it to check many things. Okay. Use that. You can use while loop for, let's say, there is a question says, find the first prime number after 100. Find the first prime number after 100. You never know where is the prime number is. Okay. So it can take what, 2 more iterations or 3 more iterations, 5 more iterations. So you have no clear idea. Okay. When you are going to get the prime number. So while loop is handy in that case. Okay. You can structure the while loop in such a way that it will end at that point when you say that you have got the prime number. Okay. Right. So there are two statements often used in while and for loops. Okay. So these two statements are break and continue. These two are jumping statements, break and continue. Continue. Okay. What break will do? Break will break the loop and the control will come out of the loop. Okay. For example, let's say I have a number n which is having a value 5 and I am having while here. So in while I have a condition, say n is less than 20, n is less than 20, and the task I'm doing inside while loop is I'm just printing the value for n, value of n. Okay, let's say n, right? Okay. Then I'm increasing the value of n equals to n plus 1. After that line, I have a condition. Okay, I'm using if n equals 10. Okay, at some place n will be 10, right? Okay, n is increasing by 1 after 5. So at that point, I'm writing break. Okay, okay. So let's start. So you can see 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Okay, after 9, n grows to 10. Then when n is 10, the loop ends because of the break statement. You are coming out, the control is coming out of the loop. Okay. So Suppose this thing is not there. Suppose these two lines are not there. So you can see the loop is going till 20. Okay. The value for n is from 5 till 20. Okay. Less than 20 actually. If you add if, you can give a condition. Okay. And tell your compiler where to stop. Right. So as I was giving you an example about finding the prime number after 100. So you can use this break. Okay. As soon as you get the number, just break the loop. Okay. So let me show you. Okay. Let's jump into that particular thing. Okay. Let's find a find find a prime. Okay. Let's say find the prime after find the first prime. Let's okay after 150. After 150, what is the first prime? What is the prime number? What is the okay? So let's say I have a for no, we are going to use while loop and n equals to 150. N is the number 150. The next number is 151. I'm beginning from 151. Okay. So suppose while while LE. So while my loop is going to run continuously. Okay. I don't know where to stop. After 150, which one is the prime number? I don't know. Okay. So I'll simply write true. Okay. I'll use this boolean value that my loop is going to run continuously because I have directly put the value true. Okay. Now it is endless loop. So where it is going to stop? Okay. So it will stop when I get a prime number. Right. So I'm going to check the factors of a number. So inside while I'm going to use the for loop, or I can use while loop for counting the factors as well. So c equals to 0 for I in range. Okay. 1 comma n plus 1. I'm using the same method for like counting the two factors. Okay. Right. So you can use, there are many methods for checking prime numbers. These are available. You can use any of them. So if let's say what c no n modulus I n mod I equal to 0, then c plus equal to 1. So there you go. I'm counting the factors of n. Okay, right? If the count is 2, if the count is 2, that means it's a prime number. So simply I'll print okay, got the prime number, which is actually I was checking for n, right? I was checking with n. So n is the prime number that I got after 150, right? So immediately I'll break. I don't allow the loop to go further to check another prime number. So at that point it will break. It will give me the first prime number that it gets. Okay. So suppose 151 is not a prime number, right? Then you need to jump into the next upcoming number. So that is n equals to n plus 1. Okay, right? Okay, I hope you understand this code. So 151 itself is a prime number. Let's say 120. After 120, 120, 121 cannot be a prime number because it's a product of 11. Okay, 127. After 120, we got 127 as a prime number. So that means after 120, how many numbers it has actually checked? It has started from 120, 121, 122, 2, 123, 124, 25, 26, then gradually 27, 127. So after checking all these numbers, you are ending up here. So basically my while loop is an unfixed loop, which is designed, this code is designed, okay, to run until it finds a value. Okay, right? Okay, you can see inside the for loop, the range is actually fixed. This is fixed for a number n. For a number n, the range is fixed. You are always going from 1 to n plus 1. Okay, but this while loop has no condition here. Okay, so you can say for loop is kind of fixed loop, fixed iteration type, and while loop is unfixed. So this is a suitable example. Okay, to understand this thing. So now, so you know the application of break. Let's know about continue. So continue will skip a step and jump to the next iteration. So let's say, suppose for I in a range, okay, range 1 comma 11. So I have numbers from 1 to 10, right? Okay. What happened? See, there's an indentation issues. 1 RANG. Aha, I am in need of a variable. So for I in range 1 comma 11. Now there you go. Okay. So print print I. Okay. I'm printing I, right? Okay. Printing I, then I'm printing I plus 1, I plus 5, like say. For every I, you are increasing, you are printing 5 more, adding 5 more to it. So 162738. So you are getting this. Okay, let's do a little bit change and equals to colon colon. Okay, there you go. Okay, now you have the pair. Let's say keep 2 dashes now. Okay, so you can see 16273849. So this is the left hand side is I and the right hand side is I plus 1. So this is I and 6 is I plus 5. Okay, so there you go. So this is how you are printing. Okay, right? Okay, now, so if I want to skip all those odd numbers or even numbers, let's say I want to skip printing of even numbers, right? So what I'll do? So I'll put a condition if I is even. So this is a condition for even. Then continue. Okay. What this will do, this statement, continue statement, is a jump statement that will skip the parts written below it. Whatever lines are after continue, these will not get executed and you are going to the next value of I. I is the loop variable. When I is 1, it's not even, you are printing it. Okay, right? These two get executed. When I becomes 2, okay, the if condition gets executed and continue gets executed. When continue gets executed, okay, the control never goes to the next line, it directly jumps to the next iteration. 3, I value 3. Okay, so when you run this code, what you see, right? All the even numbers are skipped. Okay, so basic. So now I guess you have the idea how continue works. Okay, so sometimes you need to skip some step, right? When you need to skip some step, then you can use continue. Okay, continue is followed after a condition, so there must be a condition, and for that condition you can use the continue statement to skip that particular part or skip the execution of codes below it. Okay, right? I guess you have some clear idea about for loop and while loop, the break statement and continue statement. Okay, please try to get some questions and solve them. Okay, so hope you all understand how the loop works and find some good use of it. Okay, thank you. That's all for today.